Welcome to massive open online course on chemical process intensification. In this module, in module 7, we will discuss about the process intensification by monolith reactor, and under this module in this lecture we will discuss something about the monolithic reactor, its introduction, basic properties, type and structure, and the advantage and disadvantages of this monolith reactor over other conventional catalyst type reactor. Now, as we know that there is a special structure which may increase the efficiency of the reactor based on the flow characteristics through the special structure. Now, based on that flow characteristics, the reactors are developed in different way. In this case, the reactor based on the monolithic structure is one type where the chemical engineering process can be intensified based on the that contact between the phases and also retention time and also other hydrodynamic aspects where we can get the benefit like that flow characteristics, flow patterns, even that mixing characteristics, even ideal flow or non-ideal flow, or it is a plug flow or other type of reactor based on this special structure of the reactor internals there. Now, if you make the reactor internals in such way that in the internal as a support you are using that internal for some that catalyst, so that over the support the catalyst will be that layered over the special structure of that internal, and whenever flow through that catalyst, then the reactor will be act as a catalytic reactor for a special or for a particular specific chemical engineering process where the catalyst particles will be involved there. Now, that what is that special structure and why it is called that that monolithic one type of special structure based on which that monolithic reactors are now very important for the research scientists, and they are giving more attention on this type of monolithic structure based reactor where different chemical engineering process can be carried out. Now, you will see that very ancient age where different architectural structure actually or concept that was actually used for their that building of their house in the human life, that they have actually designed their ancient stage that houses in different structure. So, in that case, one of the important structure, it is called that monolithic structure, monolithic architectural structure. Here it is see in the ancient age, this is a house is made that the that roof is made in a particular structure. There that some it is called that honeycomb structure. There is a special structure like this. So, this type of structure, it is called that honeycomb structure, or it is called monolith structure. Here like this, here see how this stepwise this structure are made here. So, this type of structure, it is called that monolith structure. So, this is architectural structure, one architectural structure there. So, in ancient age they have that used this type of that structure there, and in this case you will see that based on this architectural structure you will see that now researchers or scientists, they are thinking about that since the flow will be flowing through this structure there will have some certain fashion of the flow, and that fashionetic flow may be useful for the certain chemical engineering process to get its intensification. Now, this monolithic structure support for catalyst here, this type of that you see that this type of structure are there. This is called monolithic structure support for catalyst. That means, on this support the catalyst particles are layered in such a way that through which the that reactants are flowing, and during that flow there will be a reactions or chemical engineering reactions based on which we are getting different types of products by that intensification of the process. Now, this is called different structure. So, there are several structure also are there. So, this type of structure it is called monolithic. Actually, in the just last few decades that different types and even different structures of the catalyst are being used for particular chemical engineering processes. So, monolith is one of the important structure also. I will show that what are the different structure of the catalyst particles are used for the chemical engineering processes. So, based on this that structure, special structure of monolithic, this chemical engineering process reactors are being developed or designed to get the intensification of that particular processes. Like here catalytic reactors, they are this type of reactors are being used in that motor vehicles just to remove the exhaust that is components from the exhaust. There are some like that carbon monoxide, NOx, COX, even SOx also, to remove all those things. Catalytic converters are being used there. So, here this type of, so there are several types of other reactors are also there, that the reactors are being developed based on this special structure, and that structures are used actually for that chemical engineering process. One of the example like that transesterification to actually produce the biodiesel. So, they are also these monolithic structures of the catalyst are being used for the getting of process intensification. So, in this case we are seeing that here the catalyst are the key for the sustainable development in the chemical process industry. So, that is why whenever you are going to use the catalyst in for a certain chemical engineering process intensification for the sustainable development, then we are thinking about that how this catalyst can be used there. And about that 80% of the chemical products in the world market are manufactured via that heterogeneous catalytic processes. So, in that case these catalysts are very important, and how that catalyst particles can be used in a particular structure, so that we are getting that intensification of the process. Also, an essential tool of the chemical industry is a reactor that is procured by solid catalyst. So, in that case the reactors will be produced based on that solid catalyst layout, and the vast majority of the such reactors used in gas liquid processes, and that contains that catalyst in the form of either stationary or moving particles of various shapes and sizes. So, you are actually or nowadays that reactors are being that being developed based on that catalyst, how it should be oriented in the reactor, whether it would be stationary or the moving particles, or the moving particles of various shapes or sizes. So, in that direction it is being developed, and this monolithic structure on which that catalyst particles are that being supported, so that based on that catalyst support material as a structure of monolithic structure, the reactors are being developed for the different chemical engineering processes, that especially in multi-phase flow processes are very important. Here in this figure it is shown that some that reactors are there In this case, simple start tank reactors are being replaced by just adding that inside the reactor there will be a monolithic structure, and that monolithic structure that through which the flow will be flowing, where we can get that certain fashion of the flow or pattern of the flow, and based on which we are getting that intensification. We will be discussing later on that in details more about this type of reactors, how actually that different flow patterns are actually formed and what are the different hydrodynamics, and also based on that hydrodynamics how the chemical engineering reaction is being carried out and how it should be intensified compared to the conventional reactor. Now, before going to that actually details of that monolithic catalytic reactor, you have to know something about that catalyst. What is that catalyst? The catalyst help us to synthesize the product in a resource protective way with less consumption of energy, and in some cases without any formation of byproducts and waste. So, you have to synthesize or develop some catalyst where you can get that that reaction output with less consumption of energy and the formation of byproducts that will be more useful, and also that should not be non-hazardous there. And the catalyst, especially if they are applied in a structured way, play that important role in the so called integrated approach to environmental protection. And also this type of catalyst also that include integration of various process operations such as chemical reaction, separation, heat exchange and momentum transfer also. So, any chemical engineering process, these things are very important, that chemical reaction, separation, heat exchange and also momentum transfer. So, you are going to intensify the chemical engineering process based on this chemical reaction, separation, heat exchange and momentum transfer are there. So, in that case for the chemical reengineering reaction, if you are going to use that catalyst, you have to use the catalyst in such a way that whether it will be making a special structure or you are going to use it conventional way or not. So, since the monolithic structure are giving the that intensification of the process. So, that is why the monolithic reactor based on that catalyst on which it is being supported, the reactors are being developed for the chemical engineering processes. Now, what are the limitations of that conventional catalyst bed reactor? In that case, you will see that we are getting still now that there are several existing that conventional catalytic bed reactors where exhibit a number of known drawbacks and limitations there. Those includes like mass and heat transfer limitations are there. Low specific surface area of the catalyst, even high pressure drop and thermal instabilities like packed bed, trickle bed, even that other different types of packing materials, even fluidized bed also, the catalytic fluidized beds also there. In that case, sometimes that catalyst attrition is being happened, and also that maldistribution of the catalyst sometimes it happened, and we are not getting that 100% utilization of the catalyst surface there. So, this type of shortcomings are there. Even sometimes it is very difficult to overcome that troublesome that there catalytic separation there, and also equipment erosion in slurry systems are there. So, this type of drawbacks or limitations are there in the existing conventional catalytic reactors are there. So, that is why the development of that existing catalytic reactors to get the process intensification, it is now that being developed, and it is going towards that one type of reactor like that monolithic reactors, monolithic catalytic reactors there. Even we have discussed several other different types of chemical engineering process intensification, not only on the catalyst bed, there are several others way also to get the process intensification. So, here catalyst bed reactor is one type of where that monolithic structure can be involved. So, this type of reactors will be more useful to get the process intensification. Now, here, so researchers have shown that at least part of these limitations wherever we have discussed that can be avoided by applying monolithic catalyst there. So, there are several different types of monolithic structures are there. Here this type one. In the past 40 years or so, there has been a that gradual increase in the use of monoliths as catalyst supports are there. So, there are here sometimes honeycomb structures, and sometimes that foam structure, and sometimes it will be rod structure in which there will be that monolithic structure will be inside that rod, and these are the honeycomb structures are there. So, this type of structure is being actually developed to get that more surface area, less pressure drop, even that well mixing plug flow phenomena, so that we can get the process intensification for that particular chemical engineering process. Now, question is that what is that monolith, how it can be actually defined that. So, the monoliths are a special structure, we can say that it contain various types of interconnected or separated channels, maybe that it will be straight channel, wavy channel or crimped channels also in a single block of material there. Examples like honeycombs, foams or interconnected fibers. So, these are the different structures of that monoliths. So, that is why the monoliths is a special structure that contain various types of interconnected or you can say separated channels. That channels may be that straight, wavy or other types also. Now, where that actually this monolith term has come? The term monolith has its own origin in Greek language. It is a combining form of mono means here single, and lithos means here stone. So, mono means that is single, and lithos means stone. So, monoliths means here simple single stone there. So, in a technical context, this monolith has much broader meaning, like that generally it may be referred to as the that large uniform block of a single building material, you can say. And in that case this type of structure may be used in heterogeneous catalytic reactor, where this heterogeneous catalyst will be applied mostly as a support of a catalytically active component, or as a catalyst if a catalytic component is integral part of the monolith structure there. And that how actually this monolith construction can be done, or what are the materials actually being used for this monolith structure construction there. So, as per basic construction material, there are mostly two types of material based monoliths you can get. Generally these are procured based on that that ceramic material, and also metallic structure there. So, in the ceramic cases you mainly that cordierite type materials will be used. In that case actually this type of materials will be like silicate mineral that is found in metamorphic and igneous rocks, and also metallic there will be mainly stainless steel, metal alloys, etc. So, we can say that there are two types of broadly we can say that two types of materials are being used for construction of monolithic structure there. One is ceramic, another is metallic structure. Now, the catalyst that is supported by monolith as a substrate of the special structure there, and after the monolith is complete, a wash coat is to be applied there as per picture shown here, that deposits oxides and catalysts, and in that case mostly that platinum, palladium or rhodium on the walls of the holes there. So, one support that is to be required, that is that a wash coat to be applied that to deposits the oxides and catalyst there. And the term monolithic catalyst is used for a number of different structure there. In that case you will see this maybe that channel based structure, maybe that other different type of structure there will be there. So, this monolithic structure are different way to be made there. And annually more than 1 lakh meter cube of monolithic catalyst and catalyst supports are produced worldwide to meet the demand of related applications, as per Thorsten Boger that is reported in 2004 there. And how to make a monolithic catalyst? You will see by applying the layer of a catalytically active component or appropriate support, and then of course, it will be made to the walls where or inside the walls of the basic most frequently inert monolithic structure there. But whenever you are procuring that monolithic catalyst by applying layer of a catalytically active component or appropriate support, you have to make it with one or more catalytically active components there. Now, catalytic active components like that gamma aluminum oxide, silicon dioxide, zirconium oxide, carbon, zeolites, etc. Even one or more catalytically active components are there. They are platinum, palladium, rubidium, even zeolites, etc. are being used catalytically active components, where the supporting materials will be oxides like aluminum oxide, silicon dioxide, zirconium oxide, like this. So, this process is known as sometimes it is called coating or wash coating, and in this case this that will be done to the walls, so that the walls, that catalytic that layer will be produced, and then you can use as a the catalytic reactor for that chemical engineering process. Now, if the monolith structure is available in the required support material, the catalytically active phase can be directly deposited on the monolith, and if the monolith is not available in the required support material, then of course, this support material should be coated on the monolithic substrate first, and the support of a catalytically active components adheres well to the basic inert monolithic structure there. And mostly used this type of that catalytic reactors or as a catalytic converter in automobile, where the control of emission in the monolithic catalytic converter. In that case, that monolithic catalyst will be mixture of aluminum oxide, cerium oxide and zirconium oxide as a main components, and also insignificant amounts of other components like calcium oxide, magnesium oxides, even oxides of other rare earth elements, etc. So, this type of that materials are generally being used in automobiles to control the emission by monolithic catalytic structure. And what are the basic structure for that? The structure that depends on the purpose varies in the dimensions and shapes. Most frequently it is oval or elliptical and also square, you can say. And monolith channels or cells may be that hexagonal, round, rectangular, square or various other shapes there. In automobile exhaust purifier system generally consists of a closely packed array of small square cells there. So, in the catalytic converter there in the automobile, you will see that the monolithic structure will be that small square cells there, where it will be packed as an array there. So, this type of that structure is being used to just that getting the catalytic reactions and to remove that that exhaust gases like that carbon monoxide, carbon dioxide, sulfur dioxide, all those things. So, that is why catalytic converter converter based on this monolithic structure in the automobile industry are nowadays very important, where it is being used for that process intensification. And the geometric requirements of the monoliths, that depends on some specific requirements of the process, like that its a shape, size of the channels, even what should be the thickness, and also what should be the porosity of the wall, that is also important. And whether you are going to make it the microstructure layer or not. So, the thickness of the microstructure catalytic layer is also important there. So, you have to consider whenever you are going to make a particular structure, what should be the shape, what should be the size of the channels, if it is channel based monolithic structure you are making, and what should be the thickness, porosity of the wall and thickness. So, all these things actually that affect on your that reaction performance or reactor performance there. reaction yield there and conversion also there. So, you have to optimally design the reactor based on that monolithic structure, based on that different shape and size. And each monolith actually contains thousands of parallel channels or holes, which are defined by many thin walls in a spatial structure. Example, honeycomb is there, and the walls of the channels are coated with a porous material that contains the catalytic or catalyst layer there. And also alternatively, you can have different structure also that may include corrugated metal and a packed bed of coated pellets or other shapes there. Ceramic monoliths are also porous, and that monoliths of limited porosity. Most metallic monoliths are that non porous are there. So, that is why in that case you have to think about that whether this metallic or foam based or that ceramic based they are or not. So, ceramic monoliths are generally porous, and monoliths of a limited porosity will be there, whereas metallic monoliths are non-porous there. So, porous materials may be more useful than metallic one, but sometimes ceramic materials may not be used for certain that reactor, maybe their mechanical strength, but where metallic monoliths are more useful there because of that thermal strengths there for particular reactor and for the specific application there, where temperature is very high there. And the hole density may be from 30 to 200 per centimeter square, and the separating walls can be that sometimes 0.05 to 0.3 millimeter there. So, the many small holes have a much larger surface area than one large hole. So, in that case more reaction performance will be there because that surface area matters there. So, more interfacial area will get between the phases, and then you can get the better performance of the reactions. In that direction, the intensification of the process will be there. And also the open space in the cross sectional area that will be 70 to 87% of the frontal area should be there. So, resistance to the flow of gases through the holes will be low, which minimizes the energy consumed that forces gases through the structure. So, you have to that have the open space in a certain that optimized condition, generally 70 to 87% of the frontal area. Otherwise, you will see there may be a more resistance there. So, to get that that optimal flow by less resistance of the flow of gases through the holes, in that case you have to that design that that reactor to use that minimum energy consumption to force that gases to the structure also. So, that is why the shape and size and the channel size, channel length, and also that some other thickness of that channel, catalytic layer inside the channels, what should be that is very important there. If you are getting that a small bores is there, holes is there, so there may be that pressure drop will be higher, but maybe you have to then think about that what type of liquids are being used and also how that that channels are made. So, based on that there will be optimization based on the different variables of that operating conditions based on which you can design that monolithic structure and getting the process intensification. Also, integral or incorporated monolith structure, how to that incorporate the different structure or different catalyst particles on that monolithic structure is there. So, monolithic catalyst can also be distinguished by their integral structure also. The examples are here monolithic catalysts that comprises only catalytically active components or appropriate mixtures of catalytically active components like that vanadium pentoxide or silicon dioxide, zeolites, combinations such as silicon dioxide, vanadium pentoxide, and that other oxides also there. So, as per Armour 1994, they have given this that monolithic catalytic catalyst structure. that comprises based on these materials of vanadium pentoxide, silicon dioxide or zeolite and also combination of different oxides like this. And such monolithics are often used in the treatment of exhaust gases, that is generated in the stationary sources, like during selective reduction of nitrogen oxides with ammonium as a reductant as per Reactor et al. 1998. Now, to get that monolithic catalyst structure, that you have to have some support layer of that catalyst in that particular structure. So, this support is required to make the basic inert monolith structure. In that case, the support layer can be applied to the ceramic monolith structure by the following methods, that is given by Nizis et al. In 2001. So, as per their that observation that the support layer can be applied to the ceramic monolith structure with the colloidal solution of the appropriate support. The support is in the form of suspended particles. Even that with sol gel methods, the support is in the liquid phase also there, and with adequate suspension and other procedures also can be applied to get the support layer and which can be applied to the ceramic monolithic structure by the following methods there. So, that is why the support is required to make the basic inert monolith structure, and you have to follow to make this structure in a particular way. And the prepared support is coated with a catalytically active component by conventional methods for catalyst preparation, like that impregnation, ion exchange, co-precipitation, etc. These are the methods that by which you can that coat that prepared support with a catalytically active components by conventional methods. A catalytically active components and a support material can be coated on the basic monolithic structure simultaneously so as to achieve like required porosity, good mechanical properties, high dispersion of a catalytically active components there. And the catalyst like that zeolites that may not actually need a specific support material, and that can be coated or synthesized directly on the monolithic structure, monolithic support there. So, that is why all catalyst may not require that specific support material, but maximum cases it is required that the support is required for getting the layer of catalyst over there. So, in that case whenever you are making that support by that catalytically active components, in that case you have to that procure that support in such a way that to achieve the required porosity, even mechanical properties that should be very that acceptable or suitable range, high dispersion of the catalytically active components should be there. So, this is the case where that you have to remember that these points of that porosity formation, mechanical properties, how it is that varying, and also dispersion of that catalytically active components will be there over the support, how it will be there, that all these things to be actually remembered during the design of that monolithic structure. Typical physical data of ceramic and metal substrates for 40 CPSI monolith catalyst is given, that is as per that website here I have collected, and it is as per the information that is given in the website, that where they have actually reported that monolith supports that is structure will be in terms of cells per square inch, that is called CPSI, and in that case that what should be the wall thickness and geometric surface area, what should be that thermal mass, even open frontal area, how the pressure loss will be there. If you are considering that ceramic materials 400 specific that structure in that case the specific material of ceramic 400, in that case the wall thickness should be maintained at 6.5 millimeter as a wall foil, and in that case you will see geometric surface area you may get as 2.8 meter square per liter, and also the thermal mass at 200 degree centigrade it should be 699 joule per kg per K, and open frontal area for this ceramic materials it would be 75 percentage, and pressure loss there it is found that to be 130 percent there. Whereas in case of metallic structure there the wall thickness should be that 2 millimeter, and geometric surface area should be 3.7 meter square per liter, and thermal mass at 200 degree centigrade should be joule per kg per K, in that it will be 490 joule per kg per K. Even the open frontal area should be 89.3%, and there it is seen that the pressure loss it is 100% will be there. So, these are the comparison of typical physical data of ceramic and metallic substrates for 400 CPSI monolith catalyst structure there. And metallic monoliths are prepared for coating of metallic monolith structure with support material and a catalytically active component by the following methods like thermal, chemical and electrochemical procedures are there. Now, what are the basic properties of monoliths? So, you have to know that some properties of that monoliths. In that case whether it should be efficient monolith catalyst or not. So, in that case efficient monolith catalyst must comply with many properties. In that case low heat capacity should be there, high mechanical strength and chemical stability would be there, and high resistance to high temperature, even temperature shocks and vibrations, as well as high efficiency in the presence of fast changes in the feed composition should be there. So, these are the basic structures of the monoliths that should be known also before going to that design that monolithic structure. And also this monolithic monoliths actually the must have good heat conductivity to allow a rapid that heating of catalyst to the operating temperature, which ensures satisfactory catalytic activity. Also you have to remember that it may be worth to find a wash coat that has a thermal expansion of the same order of magnitude as the support to prevent some ruptures or cracks between the wash coat layer and support there. So, that is why you have to consider that what should be the that tolerance of the temperature of that material that you are considering for designing that monolithic structure there. It is very important because any chemical engineering reactions you will see there may be a temperature bond. Sometimes that it may be at higher temperature, it may be that exothermic reactions. So, during which there will be that formation of high temperature, even sometimes pressure will be high. So, in that case that monolithic structure should be made based on these properties of these monoliths there. So, that you have to consider all those things there before going to design of that monolithic structure. Now, what is that monolithic reactors? You will see that typical reactors are there as per ICT FREG says Republic, they are in their laboratory, they are actually procuring this type of reactors. This is called honeycomb based channel based that monolithic reactor, and in this case the reactor has shown a figure here. You will see that this reactor consists of thin parallel straight channels of arbitrary shape through which the gas containing the reactants that will flows through that channel gap. So, in this case, so it is simply a channel based that will be parallel straight channels there, that channels may be arbitrary shape, maybe that oval shape, square shape, that rectangular shape, different types of shape will be there. So, in this case monolith channels are there, you will see that identity is given there. Here monolith channels should be around here diameter will be 1 millimeter, length is 10 centimeter is shown there in the figure in this case. And whereas wall, that is metal foil, that where that is called support, in that case it would be that metal foil or ceramics types there. And in this case the thickness should be very small, it is around 100 micrometer, whereas that porous wash coat actually should be that on which that catalyst particles should be there. So, in that case it should be that of material of gamma aluminum oxides there. So, that thickness that whole diameter of that that porous wash coat, it should be is equal to 100 10 to 100 micrometer in thickness. And also catalyst sites, metal crystallines etc. of like that platinum based catalytic sites, like platinum catalyst is there. So, over that that wash coat there will be catalytic that materials there, and there this layer thickness should be 1 to 10 nanometer range. So, in this case we are getting that this how on the support, that is in the channel based support is there, and in the supports there will be wall and then porous wash coat over which that catalyst particles will be placed, and then making a layer of that catalytic sites, and through which that that gas that containing the reactants will flow, and there will be a reactions occur in presence of this catalyst layer. So, in this way that these monolithic reactors can be developed. So, in this case the walls of the channels are coated with a porous ceramic containing that catalyst layer. And also the transition from reactants to products, that will involve transport of the reactants by convective flow in the channels and also molecular diffusion toward the channel walls. And you will see that simultaneous diffusion and reactions occur inside the porous wash coat, whereby the products diffuse back into the gas and are transported out from the reactor. So, this is the monolithic reactors, how it is actually functioning, that are given to you. Now, different other also configurations you may have for a monolithic structure, where it may be useful for particular chemical engineering processes, like that integrated monolithic catalyst based on star tank reactor also there. So, in that case we know that current slurry systems, how the catalytic slurry reactors are being working, they are in the chemical engineering processes, gas liquid solid reactions are there, where this things is actually being actually that intensified by utilizing that monolithic structure, incorporating that monolithic structure, getting integrated with that monolithic structure in the star tank reactor. That integration may be into that the monolithic stirrer may be that in the monolithic structure also. Even that add on monolithic reactor there, like it may be externally loop, where that there will be reactions occurred outside that reactors through that monolithic structure, and then it is again passing through that stirrer. And then integral that internal monolithic loop reactor also there, this may be externally loop, this may be internally loop there. So, that is why you are getting the different structure of this monolithic structure for the reaction in a gas liquid solid system, where conventional that slurry system may be replaced by this monolithic reactor there. And also you are getting alternative configurations for the internal monolithic loop reactors, like sometimes that where you will see that sometimes that mechanical agitation may not be required for that particular process. So, there through the that monolithic structure there will be a the flow of fluid, it may be laminar way, that laminar flow condition and it may be the plug flow phenomena will be there through which that reactions will be actually occurred. So, this type of configurations as shown in the slides, you can get other different types of configurations. Nowadays various investigators, researchers, they are actually developing different type of that monolithic reactors, how that configurations can be done based on their different shortcomings, what is coming during the reactions and applying for chemical engineering processes. So, there may be that sometimes mechanical agitation, sometimes it will give you the more energy requirement, also that there will be internal circulation of the liquid. So, in that case, to avoid that circulation of the liquid or fluid medium, there are sometimes the channel based monolithic reactors are that internally placed, so that the mechanical part will be mechanical agitation part should be avoided there. So, this type of configuration is so based on that different that shortcomings and how it can be actually optimized, and based on which that the adaptation of the design of monolithic reactors are coming in the present day. Now, question is that what are the advantages that related to the conventional catalyst? If you are using that monolithic catalyst, and what will be the advantage over other conventional catalyst bed? So, the most important advantages of the monolithic catalysts are the high specific surface, small pressure drop, good interface mass transfer, good thermal and mechanical properties, simple scale up, and other advantages over which you can make them superior related to conventional catalysts there. So, these are the different that important advantages of monolithic catalysts. But parallelly you will get some disadvantage of monolithic catalyst. Sometimes if you are having that ceramic monolith, in that case that almost non-porous walls of channels, the radial mass transfer between that adjacent channels will be very limited, and the radial heat transfer occurs only by the conduction through the solid walls. In that case, it is not actually suitable for the chemical engineering reactions. So, due to the low thermal conductivity, ceramic monoliths are operated at nearly adiabatic conditions there. So, that is why these are the disadvantages of this monolithic catalyst. Also, the risk of cracking of the ceramic monoliths structure under conditions of rapidly changing temperatures are there. Basic design and preparation of the monolithic catalyst versus conventional ones is also more complex, and also it should be that cost effective. So, that is why the disadvantage equally refers to the ceramic and metallic monolithic catalysts are there. So, these are the some disadvantages you can say. Whereas, the advantage of metallic over ceramic monoliths also will be there, because there are two types of monolithic reactors are being developed. One is ceramic monoliths, another is metallic monoliths. So, in case of that metallic walls, in that case very thin metallic walls, approximately you can say that 0.04 to 0.05 millimeter present only minimum resistance to the exhaust gases that may prevent the accumulation of significant back pressure there, and high thermal conductivity in the metal material that may allow more rapid attainment of the necessary operating temperature and minimizing of the pollutant that emits during the that cold start phases. So, this type of that advantages of metallic over ceramic monoliths you can have. Also, you will see that the metallic monoliths also better mechanical durability, lower overall volume and load, additional design freedom over ceramic monoliths will be there. There may be that additional structuring with the channels, and provision of passive channels for metallic monoliths will be there. So, that may significantly improve turbulence and enhance heat and mass transfer in the case of that metallic over ceramic monoliths there. Some disadvantage also will have these metallic monoliths. In this case, it may limited thermal stability at the temperature over 1573 K due to melting, corrosion, etc. Even which may not or the case with ceramic monoliths is there, and the amount of catalyst on the walls in the metallic monolithic structure in a given volume of metallic monolith is much less than a comparable volume of the ceramic monoliths. Therefore, for chemical controlled reactions, the metallic monoliths may not be suitable compared to the ceramic monoliths there. So, these are the points that you have to remember why these metallic monoliths will be more advantageous than ceramic, and also why it is not advantageous in a particular cases, like if high temperature is there compared to the ceramic monoliths is there. So, that should be considered during that design of that monolithic reactors. Now, you will see there are several applications of these different types of monolithic catalytic reactors. In this case, you will see sometimes yield and selectivity are limited by the mass transfer between the phases or by the diffusional resistance with the catalyst. So, based on which based on mass transport, that hydrodynamic aspects, diffusional resistance, all those things, there are several applications of these monolithic reactors, where that yield and selectivity should be considered for that particular applications, whether it will be coming that intensified way or not. And usually that monolithic catalyst, as an example, are placed in vertical reaction vessel and gas liquid mixture, where it is allowed to flow gravitationally downwards and forming so called that Taylor flow pattern with the catalytic channel. So, in that case, hydrodynamic based that monolithic catalytic reactors also should be developed, so that whether you are getting that particular suitable flow pattern for that reactions or not, like that you may get that honeycomb structure monolithic reactor, there you may get get that what is that flow pattern of like Taylor flow pattern. That means here slug type flow patterns will be there, elongated slugs will be there. So, in that case, how the surface actually is giving that the interfacial area to give your mass transfer benefit over there just by diffusional less resistance over the surfaces. So, in that case, this hydrodynamic aspects is very important. So, based on that hydrodynamics, even that catalyst types that different applications of this monolithic structure will be there. There are several applications in environmental, some that remediation like monolithic catalysts have mostly been used in environmental applications, where high gas throughput and low pressure drop may be required. In that case, exhaust gas treatment, selective catalytic reduction, even that NOx gas reduction, scrubbing of that NOx gas, destruction of volatile organic components there, even combustion reactions also are there. So, these are the several applications are there. Even in power sector also, so more recently there has been reviewed interest in the use of monoliths for reactions, where energy efficiency and cost effective reduction of that that exhaust gases, and also that reactions for that power plant to produce that different gases, and how it will be that used for power generation there. Because their combustion will be catalytic, and also generation of the steam from that water will be one important aspects there. So, power generation, the selective oxidation of the alkanes, and preferential oxidation of carbon monoxide based on that that energy efficiency process by monolithic reactors are being applied in particular this power sector. So, that is why the applications is not only in the environment, some other chemical engineering processes also, like the Fischer-Tropsch synthesis, their gas liquid solid reactions are there to produce different types of hydrocarbons. So, there these monolithic catalytic reactors are important. So, Earlier actually the conventional way, like only in slurry reactors, that gas, liquid, solids, they are actually moving inside the bed, that is arbitrary, that means the internal circulation of the fluid medium to get that that well mixing there. But sometimes that back mixing may hinder the reaction performance. So, to remove that back mixing, this monolithic reactors are coming. Even to reduce that radial movement of that slurry fluid, they are also these monolithic reactors are being actually considered to get the more that efficiency of the reactions. And they are also that you can that other oxidation reactions also based on that monolithic structure, just replacing that that mixing of the fluid by through that just flowing through the that channel based monolithic reactors are there. So, in the next lecture we will discuss more about the applications and the preparation method of different types of monolithic catalyst. And I will suggest to go more about the that different types of monolithic reactors, even what are the different types, different structures of that monoliths, to go through this textbooks there. So, thank you for this lecture today.